Good morning, students. I am K. Saranya, Assistant Professor Max, Joseph Arts and Science College, Tirunavallur. Next, we have continue the online class. B.sc Max, third year. Subject is Dynamics. Third sum. A train moves in a straight line with uniform acceleration b in successive interval of duration t1 and t2. Show that in acceleration 2 into bracket b t1 minus a t2 dividing by t1 into t2 bracket t1 plus t2 bracket close is equal to alpha. Interval values t1 and t2, distances values a, b. So, and then solution is u equal to initial velocity u, initial velocity a, uniform acceleration. We know that s is equal to ut plus of at square, equation number a. When t equal to t1, s is equal to a is equal to alpha. Substitute in equation number a, we get, this is the diagram. First one t equal to 0, last one t equal to t1 plus t2, middle value t equal to t1. First half place value is a, second half value is b. Next a equal to u t1 plus of alpha t1 square. This is the formula of distance acceleration. So u into t1 is equal to a minus 1 by 2 alpha into t1 square. This is the equation number 1. And then before equation is a minus 1 by 2 into alpha into t1 square is equal to u into t1. First one is a equal to u t1 plus of alpha into t1 square. This is the equation. Next we have a minus 1 by 2 alpha into t1 square means a value is left side minus plus 1 by 2 alpha into t1 square value is right side. Taking the value a minus 1 by 2 alpha into t1 square is equal to remaining value is u into t1. Next u into t1 is equal to a minus 1 by 2 alpha into t1 square, equation number 1, where t equal to t1 plus t2, s is equal to a plus b, a equal to alpha. Substitute in equation number a, we get a plus b is equal to u into bracket t1 plus t2 plus 1 by 2 into alpha into t1 plus t2 whole square. Equation number 1 divide by equation number 2, we get u into t1 dividing by u into t1 plus t2 equal to a minus 1 by 2 alpha into t1 whole square dividing by a plus b minus 1 by 2 alpha into t1 plus t2 whole square. Next, u into t1 bracket a plus b minus 1 by 2 alpha into t1 plus t2 whole square is equal to u into t1 plus t2 minus a minus 1 by 2 alpha into t1 whole square. t1 into a plus b minus 1 by 2 into alpha into t1 plus t2 whole square is equal to t1 plus t2 minus 1 by 2 alpha into t1 whole square. Next, a into t1 multiplying u multiplying t1 is inside values, so a into t1 plus b into t1 minus 1 by 2 alpha into t1 into t1 plus t2 whole square is equal to a t1 plus a into t2 minus 1 by 2 alpha into t1 square into bracket t1 plus t2. b t1 minus a into t2 is equal to 1 by 2 alpha into t1 bracket t1 plus t2 whole square minus 1 by 2 into alpha into t1 whole square into bracket t1 plus t2. Next, b into t1 minus a into t2 equal to 1 by 2 into alpha into t1 bracket t1 plus t2 into t1 plus t2 minus t1. b into t1 minus a into t2 minus 1 by 2 into alpha into t1 into t2 bracket t1 plus t2 bracket close. Once again we repeat the equations. b t1 minus a t2 equal to 1 by 2 alpha into t1 into t1 plus t2 into t1 plus t2 minus t1. Next value b into t1 minus a into t2 is minus 1 by 2 alpha into t1 into t2 bracket t1 plus t2. Therefore alpha equal to 2 into bracket b into t1 minus a into t2 bracket close dividing by t1 into t2 into bracket t1 plus t2 bracket close. So we have proved that 2 into b into t1 minus a into t2 dividing by t1 into t2 bracket t1 plus t2 bracket close. This is the answer. Hence the proof. Thank you, students.